going to be talking today about a data type that we use here at ExtraHop called RemoteData. My name is Ted Driggs. I'm a principal product manager here at ExtraHop. Hence, Ted Talks TypeScript is the official name of this talk. I'm also something of a programming language enthusiast. I've written a bunch of projects in Rust. I was briefly the maintainer of the Rust auto-completions library that's used by the Rust language server for VS Code integration. And the UI team here, in what I can only describe as a fit of exuberance, has allowed me to not just publish merge requests, but to approve them. And so far, they haven't regretted it that much. All right, so I'm going to talk about some specific problems that I'm sure you've either encountered in your own UI code or you've encountered in other products' UIs over time. The first one is showing no results before results are even ready. So you open the app and it says, you have no messages. And then a second later, it's like, just kidding, you have a message. Second is you have an error, and that causes loaders to spin forever. Crashes from trying to use data when the app can't connect. This one is more that you probably haven't seen in other products, but in your own code, prop sprawl when dealing with components or state management. And lastly is you make one tiny change on the page and the entire page locked with a spinner, and then you see the results of your thing. And you ask yourself, why isn't this just an old-fashioned website? Because at least then forward and back would work properly, as opposed to what I have instead. So I went out and I found some examples of this. This one helpfully was just, I Googled for no results and loading, and this was the first picture that I found on GitHub issues. So thank you to FALM, which was the product that just happened to be first on Google. Second one, so this is from Apollo, an otherwise great app on the iPhone. If you enter a subreddit name that does not exist, it will just spin forever. Third, how many times have you seen cannot read property map or filter or something of undefined? Those of you who are not nodding, I know you are now liars. Fourth up, property sprawl. So this is actually taken from our code base. I've highlighted the is fetching booleans, so you can see how we have several places where we're checking, is fetching, and then we have detection rollups, which will be undefined prior to the first response from the server. I picked this because I was partially responsible for writing this, so I didn't feel as bad shining a light on it, but it illustrates sort of how even the best intentioned code can quickly accumulate these properties from the edge cases of dealing with asynchronously available data or data that depends on the network. Last is lack of loading states. So you'll open an app and it'll just sit on a blank screen, and you'll be waiting and wondering if it's working, and wondering whether or not there's supposed to be content there, and then you'll wonder if I forgot to put a picture on this slide. So these are 5 problems that they don't take away from the core value of what you do for your business, but they are really annoying to users, and they're really annoying to us as professional people who have to write code and have to interact with software. So unfortunately, this is not a thing that can be centrally resolved. There are some problems that are hard, but you can unleash a principal dev on them for a week or two, and you'll get a solution that can carry the entire team for months or years thereafter. This is the opposite. Every page you build, every view you build, this problem rears its head over and over and over again. And that means that you really need to find a solution that's ergonomic for the dev, doesn't get in the way of productivity, and encourages the right behaviors by default, so that you don't have to be spending a lot of time in review being like, hey, what happens if if we lose network connectivity? That's just not a productive use of anyone's time. And since this is a TypeScript meetup, now we're going to talk about how the compiler can bail us out of that situation. So I promise this is not a talk about promises. Promises are a way to compose asynchronous operations and get us out of callback hell. So they're really good for modeling asynchronous control flow. But, I don't know how many of you knew this, there's actually no way in vanilla JavaScript to check the ready state of a promise that you are handed. So if you accept a promise in a function, you cannot figure out whether or not that promise has finished yet. So what's missing is a way to synchronously check readiness of a promise that you did not initiate, do not own, and don't really care about doing something yourself when it ends. You just need to represent the snapshot of that promise at a point in time. So that's where RemoteData of T comes in. So RemoteData of T is a type, some utility functions, and a lot of doc comments that are inspired by an Elm type of the same name. So this is the simplified signature of RemoteData. It's either not asked, i.e. I've not started the promise, or like I've not started the operation to get this data yet. Loading, I'm in process of getting this data. The value being represented by the RemoteData, or an object that has this failure property set to true, and then an error of unknown type. So the error of unknown type, you may or may not know, promises the catch passes any. We have a lint that bans the use of any in our company because it is dangerous. So we use unknown for that, and we felt that was a better way to represent, like, something went wrong, so all of your assumptions about type safety have just been chucked out the window. So you can recover, but you need to do runtime guarding of your error values in that case. So some of the utility functions that we have exposed are things like RemoteData.isReady, which takes as its first argument a RemoteData of T and returns a Boolean that is a type guard. How many people in here have written a TypeScript type guard function before? All right, how many of you have not written one but know what one is? Okay, so in TypeScript you can have a function whose runtime return type is Boolean and whose declared return type is blah is foo. So if you have a function that takes an argument of blah, you can actually narrow that type by saying, okay, if this function returns true, then TypeScript should treat it going forward as if the type of blah was explicitly declared to be foo. So RemoteData.isReady does that narrowing, so you can write if RemoteData.isReady and then use the value as if it was just the bare value going forward. RemoteData.unwrap basically says, hey, either you're ready or we're crashing. Like, which is useful if you know that the thing is ready at that point. You just need to tell the compiler to get out of the way. Then we have some transformation functions and some composition functions. There's about 12 or 13 of these in the actual package that you can use to stitch together RemoteDatas. So here's an example of that guarding thing. You can see how it takes a RemoteData of T, and if the thing is ready, it will actually then let you use the value you passed in as if it was just T. Here's another one. So this one is just like a regular map where it transforms the thing. So if the thing is ready, then your map function will be run, and what you'll get back is a RemoteData of the output of the map function you provided. All right, so we use React for our UI, so I'm going to talk a little bit about how this fits into a React world. So we have components that accept RemoteData of T to indicate that they can start to render themselves before that data is available, and they will handle loading states in a way that is appropriate for them. So that helps solve one of the problems that I mentioned earlier of the entire page has to bounce back to loading. We can now have components say, hey, I don't need this thing to be ready, I just need to know if it's going to be ready or if it's an error, and I'll take care of the rest. So that already makes it a lot simpler to sort of do page construction where you can build pages out of these larger blocks that can be rendered all at once, and then can internally present nice loading states together. And you can wrap that in an outer thing to sort of say, okay, until one of you is ready, I don't want to show 3 spinners. So I'll show 1 spinner, and then once one of you is ready, we'll fade that in, and we'll just have 2 spinners for the parts that aren't ready yet. We've also started using a lot of hooks in conjunction with RemoteData. So we'll have hooks that do complex data operations or data loading operations, and then return values through React State API to cause re-renders automatically when data resolves. So it feels a lot like you're using asynchronous operations, except that they're technically truly synchronous and you're in full control of the UI at all times. Good example of one of these components is called RemoteDataPanel. So I lost my syntax highlighting here. Thank you, Google Slides. We have a RemoteDataPanel that takes a data, which is some remote data of my thing, takes a failure renderer, which is what it's going to show in this place if the remote data comes back as an error, and then says, well, we're going to wait 300 milliseconds before we show a loading spinner. So Mike, who's standing over there and is one of our designers, really doesn't like when we pop spinners in for like, a 20th of a second, because it's just long enough for someone to see and just short enough to become truly useless. So the delay property gives us a lot more control over how that visual effect happens, but it's very simple for us to add that incrementally to a page and not have to sort of think about it in a really complicated top-down kind of way. Once the data is ready, we pass that to the callback in the center, and in this case, that would just render a paragraph with whatever the text was that we've been waiting on. We've also now started adding some specialized components for things where it's like, hey, I need the name of some device. That may or may not require a server call, so we have a little tiny component that just says, hey, show nothing until you know what this device's name is, and then bring the name into the UI. All right, so let's talk about why you should care and why you should totally go and adopt this in your project. First off, this is completely type safe. Because the value itself is wrapped from a type perspective, you can't forget to check the is foo loading or is foo error properties. Like, the compiler will not let you access members of the object that you're guarding until you've satisfied it that either you know that it's ready or you've unwrapped it to say crash if I'm wrong, and then it will be very unsubtle if it fails at runtime. It's also very easy to narrow, so we have all the utility functions that make it really easy to work with before and after it's available. Another important thing here is any value t is a remote data of t. So there are some other libraries that have done this, and we made a specific sacrifice in ours where a remote data of t is indistinguishable from just a remote data of t. So if any of you are real type purists, you just threw up a little bit because it's not strictly monadic. It doesn't recurse. But the advantage of this is twofold. Number one, there is zero allocation done for us to add remote data support to a component. To be truly monadic, we would have to put an object around the thing that said, hi, I'm a remote data in the success state, so that we have a second object saying, hi, I'm a remote data wrapped around a remote data. With our version, you don't have that trade-off. If you've just got an array of some things, you can pass that to a function that expected a remote data of an array of those things, and it works just the same. So that made us a lot more comfortable rolling this out widely across the UI, knowing that we weren't incurring object allocations and breaking referential equality all over the place in pursuit of this type safety. Also, because not asked and loading are consts that are declared in the module itself, every not asked state is equivalent, every loading state is equivalent, and there's no allocation to use those in maps, in caches, or anywhere else. I mentioned already, if you were passing a t to some function, and that function switches to accepting a remote data of t, the calling code doesn't have to change. So you don't see the need for pull requests that have to go touch 50 files because one widely used function now wants to support its own internal asynchronicity. Everyone that was calling it before is fine calling it still. Also, remote data is serialization safe. So if you are using Redux or any state management system that persists to disk, unlike promises, remote data totally can be frozen down, and on rehydration back into memory, you can look for anything that was in flight as loading and recognize that those are the requests that you should go start up again, because when you last serialized, those are the ones that were frozen as, hey, this is in flight right now. Lastly, remote data is stateless. Like, a promise has fixed state transitions where it goes from not existing to running to either resolved or rejected. It can't go backwards, it can't resolve itself again, and that's great for modeling operations, but it's not great for modeling UI data where you don't want the UI to be opinionated about when that data is updated or how that data is updated. That makes it a lot easier to simulate different loading states in things like Storybook when working with React components, and the fact that the asynchronous availability of data is not attached to the actual fetching operation means you can do background updates into caches that are away from the UI, and then push those in as just data changes, and get live updating pretty easily in a centralized way. Some of you may have seen this morning, there was a Twitter thread from the creators of React about Suspense and how that's going to change React, like working with promises in React. We're pretty excited about that, and we're tracking it closely, but we still found that this is a very useful tool for modeling data that doesn't control the operations, but instead is just a witness to them or to the data that they produce. Yeah, so lastly, as of today, we actually made this available as ts-remote-data. It has no dependencies and is very tiny, so feel free to go ahead and install it, try it out. If you have any feedback, there's a GitHub for it, and we look forward to engaging with you. All right. Any questions on any of that?
How are the docs? Are they thorough?
So I'm a little obsessive when it comes to doc comments. So I think that they're pretty good. Obviously curious to see what someone who goes in cold sort of what their experience is, but everything that it exposes is documented explaining what it is and why you would or would not use it. So,
but it's mostly in the code itself. There's not as much in the README right now, right?
Right.
But as JS docs.
Right. So it's all in, if you're using VS Code or an editor that does provide that, that's all there, but we do need to do some work on building out, like Nello mentioned, the README and sort of the examples and stuff that go with it.
The code is also just one file, though. It's very approachable.